In this lesson, we're going to be looking at grade 12 compound angle identities, which are fully examinable. The first proof of the compound angle identity is not required because it's already given. It's always going to be given, this one. So you don't need to know how to prove this one, the one of cos alpha minus beta. But this remaining three, you need to know how to prove them, right? Okay, I'm going to show you how to prove each and every one of them. Okay, we're going to start with 2. Ne? So for 2, okay, let me write 2. We have cos alpha plus beta. Okay, so cos alpha plus beta, right? So, ladies and gents, we're going to always use that one as our reference proof. Ne? So this is what I'm going to do here. I see, okay, I have a cos, I have a cos. I have alpha, I have alpha. The only difference is this one, there's a minus, and this one is a plus. Then there's a beta and a beta. So the exciting thing is this. I can always convert what? A plus to 2 minuses, right? So this identity, I can write it as this. Cos alpha, this plus sign, I'm going to convert it to minus negative beta. Okay, remember minus and minus still give me this plus here. So I haven't changed the meaning of this one. I still have a plus there, but I represented it in terms of a minus. Why am I representing it in terms of a minus? Because of that minus there. Okay, good. So now I want to show you something. Let's do this. I'm going to take this identity and write it there. We have cos alpha minus negative beta, and then closed. So I want us to compare these two identities, right? This one and this one. If you check here, right? If you check here, you are going to be having the same thing. The only difference is now this. Where there was beta is now negative beta, right? So basically it means we're just rewriting everything, but we're replacing the beta by negative beta. So where there's beta, I'm going to put negative beta, right? Perfect. Then this is going to be, so we're going to rewrite this, right? So we're going to have cos alpha, then cos negative beta minus, plus, this plus there, plus sine of alpha, and then sine of negative beta, right? Then we need to do reduction now. Remember, if you haven't watched our videos before this one, please watch them, then you'll know your Cartesian plane. Remember, negative beta is in the fourth quadrant, right? Which is the quadrant for cos, right? So I know that this one is going to be positive cos beta because we're in the quadrant of cos here. So here, nothing changes. I still have cos alpha, cos beta, right? But this one here, I'm having negative beta and is a sign, and we're in the fourth quadrant. So the sign is negative in the fourth quadrant. So this positive here will be affected by the negative sign from this function here. So it's going to be negative sine alpha sine beta, right? Remember, ladies and gents, this is cos alpha plus beta. Okay, then I have proved this one. So the compound angle identity for cos alpha plus beta, it's cos alpha cos beta minus sine alpha sine beta. I want us to check the differences between identity 1 and 2. We have, if we have a minus here, né? In the middle, you're just going to have a plus. Do you see it? But it's cos, sine, sine. If it's a plus here, in the middle, you're going to have minus. That's the difference. But this proof, you need to know how to do it. Ne? It's entirely examinable. Okay, perfect. So now we're going to prove the ones for sine. Ne? Awesome. Okay, so to prove the one for sine, we're going to firstly use this effect. Ne? Remember, sine A, right, is the same as cos 90 degrees minus A, right? And then also sine 90 degrees minus A equals to cos of A, right? And then we're going to use these two ideas to prove our trigonometric compound angle identity. Perfect. And then now we're going to use this idea. Okay, this one I was just showing you, so I'm just going to erase it. But it's also important, okay? So now here, we're going to use this one. But we're firstly going to let angle A, right, be equals to those two angles there. So let it be alpha minus beta. Ne? Therefore, we agree that when we substitute back, we're going to have sine alpha minus beta is equals to cos 90 degrees minus into bracket alpha minus beta. Remember, if you minus in by two terms or more than one term, you always put brackets, ne? And then you close that one, right? Perfect. And then this is basically sine alpha minus beta, right, is equals to cos 90 degrees minus alpha plus beta. Here, remember, there's an invisible one here, right? So I'm basically distributing the -1 inside. So -1 times alpha is just negative alpha. And then -1 times negative beta is positive beta, right? Therefore, I can write sine alpha minus beta as cos of 90 degrees in bracket minus alpha, then plus beta. Perfect. So if you check here, guys, I want to show you something. This identity, right, this one, is equivalent to this one, the one with a plus there, right? But the only difference is where there was alpha, we now put what? 90 degrees minus alpha here, you see? So you have cos alpha plus beta. But where there was alpha, it's now 90 degrees minus alpha. Do you see? So we're going to replace all alphas here by what? By 90 degrees minus alpha. Can we do that? Okay, so we're going to have cos 90 degrees minus alpha. And then this one is cos B. The B still remains the same. So cos B. And then minus. Remember, every alpha, we replace it by 90 degrees minus alpha. And then we have sine B. Right. Remember, this is still sine alpha minus B. Right. And then remember, the cofunctions rule says, if I have 90, cos changes to sine. And then here it's 90 minus, so it's positive. So it's just going to be positive sine alpha, right? If you don't understand why I'm saying it's positive, please make sure that you watch the very first video in this playlist and come with order. Make sure you're watching the videos in order because these are like textbook questions that are following each other. Né? It's a build-up type of a knowledge. So you need a prior knowledge before you can get this one. Okay. Then you have cos B there. And then here, it's in the first quadrant, but sign changes to cos because of the 90 degrees. So you have minus cos alpha sine beta. And then you have proven this identity of sine alpha minus beta. Sine alpha minus beta is basically sine alpha cos beta minus cos alpha sine beta. Okay. And then from this one, we can now easily prove the one of sine alpha plus beta. So sine alpha plus beta can be written as sine alpha minus into bracket negative beta. I'm trying to write this in that form. You see, remember this is still a plus here. Negative and negative still gives you that plus there, right? Awesome. So I didn't change the meaning of that one. But I'm seeing, okay, here I have sine, I have sine. I have alpha, I have alpha. I have minus, I have minus. Where there was B, I'm having negative B now. So which means into this diagram here, where I see B, I'm going to put negative B now. So I have sine alpha, then cos negative B, because where I see B, I must put negative B because of this. Where there was B, there's negative B now. Then minus cos alpha sine negative B, right? Remember this and this is still the same thing. So I can say, therefore, sine alpha plus beta equals to sine alpha. And then here it's in the fourth quadrant. Remember, in a Cartesian plane, a negative angle is here. Then this is the cos quadrant. So this will be what? Will be still the same because we have a cos and we're in the quadrant of cos in the bracket. So we're just going to have cos beta. And then here, we're in the quadrant of cos, but we have sine, so it's going to be negative, right? So the negative from here, this will be negative. So this negative and that one will multiply together to give us a positive. So here we're going to have plus. Then you're just going to have cos alpha sine beta, right? And that is the last compound angle identity, right? And then below here I have, so all these three are all examinable. You must know how to prove them the way I've proved it. If you don't get this, please repeat the video and over and over and over again until you get it. Okay, and then now this is the summary basically of your compound angle identities. Let me bring them a little bit up, sharp. So I want you to observe something, yeah? If you have cos, cos is always cos, cos, sine, sine. Do you see? Cos is always cos, cos, sine, sine. And then the signs for cos are opposite. If you have a minus here, here you have a plus, you see? If you have a plus here, you're going to have a minus. Perfect. Those are the two compound angle identities for cos. And then let's check sine. Sine is always sine, cos, cos, sine. So it's what? Sine, cos, cos, sine. Sine, cos, cos, sine. You see? You must know the order. Cos is cos, cos, sine, sine. And then sine is sine, cos, cos, sine. Then the signs are the same for sine. If it's negative, it's going to be negative. If it's positive, it's going to be positive. I hope this video was helpful, ladies and gentlemen. Please don't forget to hit the subscription button and to share with family and friends. See you soon. Aluta continua. Tango.